Hello everyone, welcome to a new tutorial on algorithm. Today we want to start talking about dijkstra. Dijkstra is uh, a method for is a graph used for calculating the shortest path for weighted directed graph. We have the following graph, but let me just give the vertex names v1, v2, v3, v4, v5, 6, and v7. We want to calculate the shortest path for dijkstra. So how we can calculate the shortest path for dijkstra? The method actually is not a big, is not hard. It's easy. You can implement it. The first thing that you need to do is you just pick up the vertex. So and initially, first thing actually I want to make is make the table. So we make the table, and here we put the vertices, and we have v1, v2, v3, 4, 5, 6, and 7. And up here we put k, which is known, which has a value either 0 or 1. And this is the first thing. You need to make about 1, 2, 3, 4, 5, 6, 7, 8, which is the number of vertices plus 1. So we need eight columns. So we just fix it until I finish. Okay, first thing you need to put k and d, which is the distance, and p for previous. So this is the value. You need to repeat them 8 times the number of vertices plus 1. So until I finish the table, I'll back. Okay, after finishing making the table, we begin. First stuff, you need to put the first column of the table to be the vertex is as initial state, put all these as zeros, and these also must be zeros. Okay, and the distance also, the first one, when we start at the initial point, the distance to v1 is 0, and this has to be infinity, 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 and infinity. Next, we move to the next value. We start with k v1, so we put 1, and the rest of the vertices need to be 0 because the only known is v1. And the distance to v1 is 0, and okay, the vertex is, or let's say v, I said v, but it's better to be p. So p, let me just make it to p. So as you can see here, just I want to modify v to be p, which is more understandable. So the previous for v1 is nothing, so you can put null or you can put 0 or put 0. And I repeat these values because there's one here. I repeat all these values for the rest of the row: 1 0 0, 1 0 0, 1 0 0, 1 0 0, 1 0 0. This is the first thing. After that, I calculate the distance from V1 to V2, and from the graph above you can see it's 2. So from V1 to V2, the distance is 2, and the previous is V1 exactly. From V1 to V3, from V1 to V3, let me just, okay, from V1 to V3 there's no distance, so this is infinity and this is null, put it 0. From V1 to V4, the distance is 1, and from V1 to V4, the previous is V1 exactly. From V1 to V5 there is no distance, so infinity, this says 0 from V1 to V5. Great. From V1 to V6, there infinity 0. From V1 to V7 also infinity and 0. Okay. Next we just look for this value that we have 2 here, we have infinity, we have 1, so we take the minimum, and because this is the minimum we'll put this 1 and V1, and we repeat this process for the rest of the rows. 1 1 V1 1 1 V1 1 1 V1. Okay, so okay, so we know V4 and V1. So we need to move to the next edge. We can move V4 to V3 or V1 to V2, but it's better to start from the beginning. So V1 to V2. So V1 to V2, 0, 2, and the V1, and V3. We want to move to V3. We can move from V1 and we can move from V4, but it's better to take the minimum. It's better to take. Okay, it's better to take the minimum cost. So, okay, in other words, we want to move from V1 to V3, but there is no direct connection. The way that we can move to V3 is V1, which is V1 to V4 to V3. So in this case, we take 1, 2, which is 3. The distance is 3. So here we put 0, 3, and the previous is V4. Okay. In the same sense, since we want to move from V1 to V5, so V1 to V5, we need to follow V1, V to V4 to V5. So 1, 2, and this is also 0, 3, V4. So let me just make it V4. Okay. After this, we want to move from V1 to V6. So V1 to V6, we need to, there's no direct way, so 1, 8, which is 0, 9, V4, and last one is V7, 1 and 4, which is 0, 5, V4. After this, we need to compare the cost, where the minimum one, we take the minimum one of these. So as you can notice, we have V5 and V2. Just V2, so we put 1 here, and this is very similar to the minimum spanning tree, which is a prime algorithm. So if you understand this, I promise you that you will be you hit the nail on the head. So that will be easy for you to understand the prime algorithm easily without any difficulty. So sorry, this is just to we just repeat the whole process. V1 1 2 V1. So we are we know V2, so we go to V2 and circle it. Um, cool. After this, V1, V2, V3, we need to go to V4. So from V1 to V4, V3. Okay, from V1 to V3. As you can notice, um, from V1 to V3, there's no direct way. So we need to move from 1, 2, so it will be 0, 3, V4, and we want to move from V1 to V5. So from V1 to V5, so the same thing will be 0, 3, V4, and from V1 0, 9, V4, and 0, 5, V4. So compare these values. We have a minimum. You have the choice. You have the freedom to choose which one. Um, but I think you can choose uh, in the alphabetical order. So we take V1, V2, V3. It's better to take V3. So 1, 3, V4, 1, 3, V4, 1, 3, V4, 1, 3, V4, and just we continue the whole process. Okay, we continue. We have a 5. Okay, so don't forget to just circle V3. So I need to circle V3. So after that, we need to move from V1 to V5. So V1 to V5, we go this way, we go this way. This is okay. V5 remain the same. So 0, 3, V4. Okay. Okay, 0, 3, 0, 3, V4. Okay. Okay, we need to move to V6. So we go from this with this is 9. We go this is this way, this way, this way. 1 plus 2 is 3. Okay, this is more cheaper. Minimum cost. So we go from 0 to the cost is 8, and the previous one is V3, and the same thing we go to V7. So from V1 to V okay, this is so this is nothing changed here, as I guess nothing changed. 0, 5, and V4, and we just make a comparison. It can be obvious that 5 is the minimum, so we put 1, 3, V4, and repeat the whole process. 1, 3, V4, 1, 3, V4. Okay, we just circulate V5. Okay, after that, we just we want to go from V1 to to V6, and you can do that. So we just move from V1 to V1 to V6. So the cost is, I'm sorry for this, 0 8 V3. And okay, and I want to move also from V1 to V7, so it's also be 0 5 V3. So compare the both results. I got 1 5 V3, 1 5 V 1 5, I'm sorry, 1 5 V3. And last thing, I have V6 here. And okay, don't forget to circulate a V7. So if you want to move to V6, you can go this way, you can go this way, and there's a new way here which is cost you just 6. So V1 to V4 is 4. So it's 0 0 6, and the previous one is V7. So as a matter, we just okay maybe you notice that we have a problem because we just in the writing we forget to copy 4 about 3. So this is 4, this is 4. So we end up with this solution. We end up with this solution. So this is the final step. So we have all ones here, so that means we finished. So we need to map this into the shortest path. So what is the shortest path for this algorithm? So we just pick up a new color. Let me choose a different color. Okay, this is cool. No, I don't want to change. So this is cool. The first step is that V1 to V2. So V1 to V2 and V4 to V3, V4 to V3, and V1 to V4. Okay, and V1 to V4, V4 to V5, and V4 to V5, V7 to V6, V7 to V6, and V4 to V7. So this will be the minimum shortest path. So as you can see, this is the minimum shortest path, and the cost of this is let me check. It's about you can calculate it. 2 plus 1 plus plus 2 plus 2 plus 4 plus 1. So we got 5, 7, 9, 12. So this is the minimum cost of this problem. Thank you for watching, and see you next time. Ahmed Nasser, Stereo 007 at YouTube. Thank you for watching. See you in the next tutorial about algorithm. Okay, if you want to see, you can see here's the other demonstration of the dijkstra, and you can see the green connection. Thank you.